Understand the problem first. This is a cylinder. You can see its length L, the radius of its cross section is R, and moment of inertia of this cylinder, solid cylinder, above the perpendicular bisector, means above the perpendicular bisector of its length, is I. Problem is, the question is, for what ratio L to R I has minimum value. First I will explain that this is not a rod. By rod we understand a long body with a comparatively insignificant area of cross section. This is what is known as a rod. But this can hardly be called a rod as its area of cross section is not insignificant when compared to its length. So the formula that we know about the moment of inertia of the rod about a perpendicular bisector, which is m L square by 12, where m is the mass of the rod and its length is L, is not applicable in this case. Why is it not applicable? I will explain. When we derive this expression, we consider a small element of the rod, and its mass is dm, distance of the element from the axis of rotation is x, and we write that the moment of inertia of this element of the rod about perpendicular bisector equal to dm into x square. So we have used the formula moment of inertia equal to mass into distance square. Obviously, in our understanding, we have considered this as a point mass. That's why we have been able to apply this formula dm into x square. Okay, taking this to be a point mass. Okay, in this case, this is not applicable. In this case, this element, the element which significantly large radius of cross section cannot be assumed to be a point mass. Definitely not a point mass. Point mass. Hence, for this element, moment of inertia about axis of rotation cannot be written as di equal to dm into x square. This is incorrect. This is not valid. Okay. So, in absence of a ready-made formula for the moment of inertia of such cylinder about such axis, we'll have to find a formula. Okay. Then we'll think about the question that maximum minimum, that will come in the second part. First we have to find the moment of inertia of this body about this axis of rotation. Step 1. Step 1, moment of inertia of the given cylinder about this axis. I will mark this axis as y dash, about y dash. So we will have to consider the element. This is the element that we are considering at a distance of x. So element, I am showing the element here. We know the moment of inertia. This is actually a disc or a cylinder of very small height. The moment of inertia of this cylinder about this axis is dm into r square by 2. This is a standard formula and it is known to us. From this, we will find the moment of inertia of this body about this axis. About this axis of rotation. Now I think it is clear. So we get the moment of inertia of this element about this axis by applying perpendicular axis theorem. So about this axis the moment of inertia is, as we know, it is IZZ dash by 2. So if you take this to be ZZ dash, then I Y by I about this axis will come afterwards. About this axis, IZZ dash by 2 equal to dm into r square by 2 equal to dm into r square by 4. Then we will move from this axis to another axis, which is y dash, and this y dash axis is parallel to zz dash axis. Y dash is parallel to zz dash, and moreover IZZ dash, this is IZZ dash, and IZZ dash is through CM of the element. IZZ dash, this is through the CM of the element. This is the center of mass of the element. So IZZ dash is through the CM of the element, and y dash is parallel to this. So I will now apply parallel axis theorem. ZZ dash y dash, zz dash, y dash, the distance is x. So about this axis of rotation, I y dash equal to ICM. I have used parallel axis theorem. ICM plus dm into this distance square. ICM is, this is ICM, dm into or I will replace ICM by IZZ dash. IZZ dash equal to dm into r square by 4 plus dm into x square. This is what? This is IYY dash, since we have considered a very small element, a small mass. So we should better write is that it as DIYY dash. Similarly, this is DIZZ dash. Okay. So I think now you have understood that we have to integrate this in order to find the moment of inertia of this cylinder, of the entire cylinder about axis YY dash. Or before we go for integration, let us simplify it further. dm, I write dm as lambda into dx, where lambda is the mass per unit length of this cylinder. Mass is m and its length is l. So lambda equal to m by l, that I will put afterwards. Lambda into dx into r square by 4 plus lambda into dx into x square. Okay, equal to, so this is the expression. Now I will go for finding IYY dash. Hence IYY dash after this IYY dash integration lambda by 4 r square dx plus integration lambda x square dx. Okay, equal to lambda is mass per unit length. So let us replace it by m by l. So integration, I have not put any limit now, m by l into r square into dx plus integration m by l into x square into dx. Okay, I have already told you that I am just finding the moment of inertia of this body now. Okay, so that means at present mass of the body is fixed, its length is also fixed. Okay, mass and volume they will not change. So mass is fixed, volume is fixed, length, radius all are fixed for this calculation. Equal to m constant, 4l constant, r square constant, integration dx m by l integration x square dx equal to m by 4l into r square into x. X is minus l by 2 to plus l by 2, limit, plus m by l x cube by 3 minus l by 2 to plus l by 2 equal to or IYY dash equal to m r square by 4L into L square, see x now. So L by 2 minus L by 2, that means L into L plus M by L to L cube by 8, 8 3 is a 2, L cube by 8, L cube by 8 means L cube by 4, 4 3 is a 12, 4 3 is a 12, L cube by 12, so we get this, mr squared by 4 plus ml square by 12. This is the moment of inertia of this body about this axis. Okay. Now, in order to make this moment of inertia minimum, we will have to identify the variables. So now, consider a situation in which we can increase the length or decrease the length. Accordingly, if we increase the length, the radius will drop, and if we decrease the length, radius will increase. So, for minimum I by dash, d I by y dash by d L equal to 0. Okay. So, to simplify this differentiation, I will write r square in terms of L, because volume of this body is constant, mass is constant, volume is constant. Or d by dl I y dash m, we know b equal to pi r square into L. So replace r square by b by pi L. M b by 4 pi L plus m L square by 12 equal to 0, or m 0, or we can write d by taking m outside and 3 and 4 outside, b by pi L plus L square by 3 equal to 0, or b by pi into minus 1 by L square plus 1 by 3 into 2L equal to 0, differentiating this, or minus b by pi L square or plus equal to 2L by 3, or L cube 2L cube by 3 equal to b by pi, but b by pi, b equal to pi r square L, pi cancelled, or we get finally L square by r square equal to 3 by 2, or L by r equal to 3 by 2. This is the answer. Body of mass of the body is 10 to the power minus 2 kg, moving in a medium and experiences a frictional force F equal to minus kV square. So minus sign denotes opposite to its motion. It is moving with some velocity. When the velocity is v, the friction force is k into v square. Okay, its initial speed is v naught. At t equal to 0, At t equal to 0 the speed is v naught. T equal to 0, v equal to v naught. After 10 seconds, its energy after 10 seconds is given at t equal to 10 seconds. Its energy is 1 by 8 mv naught square. Energy, obviously kinetic energy, is 1 by 8 mv naught square. Find the value of K. This is the problem. If equal to minus kv square or m into dv by dt minus kv square or minus k dt or m integration d by v square minus k into integration dt limit of t 0 to 10 second v initial velocity, final velocity can be calculated, final energy is given half m v final square equal to 1 by 8 mv naught square or vf equal to v naught v naught by 2
v naught
vf equal to
v naught square लिख दीजिए ना
v naught by 2, so v naught by 2 or m into v minus 2 plus 1 minus 2 minus 1 by v naught by 2 minus k into 10 or minus m v naught by 2 means 2 by v naught by 2 by v naught minus 1 by v naught equal to minus 10k or minus m by v naught equal to minus 10k or k equal to m by 10 v naught. Now the values are given. M equal to 10 to the power minus 2 and initial velocity 10 meter per second equal to 10 square means 10 to the power minus 4. So option 10 to the power minus 4, option 3. Hence is correct. Before solving this problem, we can eliminate some of the options by dimensional analysis. What is the dimension of K? Eliminating options doing dimensional analysis. Dimension of K, F equal to kb square or dimension of K equal to F by V square ml t minus 2 V square L square t minus 2 equal to m L minus 1. So kg per meter. So two options have kg per meter. Hence unit of K is kg per meter. So option 2 is eliminated. Option 2 cannot be correct. Option 4 is also cannot be correct. Observation: capillary diameter of the capillary is measured diameter of the capillary is measured, and height to which the liquid has risen is also measured. And this height is h, value of h is given, value of diameter is also given. You have to find the possible error in the value of surface tension. Okay. So first use this. Use the formula T equal to RHG by 2 into 10U. Okay. Or doing dimensional analysis we get del T by T equal to del R by R plus del H by H plus del G by G. Okay. What is the error in surface tension? Del T is the error in surface tension. Del R, you have to get del R, you have to get del H. And what is the error in del G? Error in del G is nil because you have taken the value of G. Okay, you have not measured it. Since you have not measured it, del G by G, this will be taken as 0 because this is not a measured quantity. So this whole thing is 0. Okay, this is equal to multiply both sides by 2 plus del H by H. So 2 into del R is obviously del D, error in diameter, by D plus del H by H. Okay. Now in order to know the maximum error in diameter, you are supposed to know the instrument which you have used to measure the diameter. If you have used a millimeter scale, then its least count is 1 millimeter and maximum error in the value of del D will be 1 millimeter. If you have taken a vernier scale, then least count is 0.1 millimeter. Accordingly, the error in del D, maximum error is equal to least count, that will be 0.1 millimeter. So similarly del H, if you have used a millimeter scale, maximum error in H is 1 millimeter. If you have used a vernier, maximum value of del H is 0.1 millimeter. So you will have to know which scale you have used for measurement purpose. Okay, so I will go through this value D equal to, I will go through this value D equal to 1.25 into 10 to the power minus 2 meter in order to know which scale you have used. Okay, this is how much? 121.25 into 10 to the power minus 2 into 1000 millimeter equal to 12.5 millimeter. Okay, I will also write the value of H. H equal to 1.45 into 10 to the minus 2 meter into 10 to the power minus 2 meter. When this is converted to millimeter, this becomes 14.5 millimeter. Now you decide which scale you have used to measure D and H. Have you used a millimeter scale? You have not used a millimeter scale because the least count of a millimeter scale is 1 millimeter. But here we find a least count of 0.1. Okay, because your reading is not 12 millimeter, 12.5 millimeter. That means the device or the scale that you have used is capable of measuring 0.1 millimeter. So obviously you have used a vernier caliper. Okay, so conclusion is, hence since least count equal to 0.1 millimeter, hence vernier caliper has been used for measurement. Vernier caliper has been used for measuring D and H. Okay, so whose least count is 0.1 millimeter. So what is the maximum error in the diameter? Obviously it is 0.1 millimeter. Put the value of D. D is how much? 12.5 millimeter. How much is del H? Del H, maximum value of this is 0.1 millimeter by 14.5 millimeter equal to 1 by 125 plus 1 by 145. Calculate this and convert this into percentage. Magnetic needle North pole, south pole. It is placed in a magnetic field. There is a magnetic field. So in this direction there is a magnetic field. So magnetic field will exert force on magnetic poles. That means, let us have a top view. Magnetic field. This is the magnet. North pole, south pole. On north pole, force acts in the direction of the magnetic field. On south pole, force acts opposite to the direction of magnetic field. As a result, this will start oscillating about its main position. Okay, and this oscillation is simple harmonic, and for this oscillation time period is given by this expression 2 pi root over I by m into v, where m is the magnetic moment, that means pole strength into 2L, and v is the magnetic field in which the magnet is suspended, magnetic field, and I is the moment of inertia of the magnet. Okay, so in addition to this, we have two more such formula. One is obviously for a physical pendulum. If you have a physical pendulum, say physical pendulum, this is a physical pendulum, this is the center of gravity, and this is the point of suspension. The distance between the two is d, and its time period is t equal to 2 pi root over I by mgd, 2 pi root over I by mgd. Then one more such situation, torsional pendulum. Torsional pendulum, it's oscillate about this, and in the case of torsional pendulum, the formula for time period is 2 pi root over I by k. What is this k? Torsional constant. This is not spring constant. This is torsional constant. Torsional constant. Okay, and the common situation is this. Time period t equal to general expression 2 pi root over m by k. This is spring constant. So there are four such expressions. Time period equal to 2 pi root over m by k. Time period for singular harmonic motion along a line. This is along a line. T equal to 2 pi root over I by k, where k is the torsional constant. Okay, and how do you get torsional constant? What is the formula for getting torsional constant? Restoring torque equal to k into what? theta. Torsional constant you get in this way, restoring torque equal to K into theta. How do you get this?
F equals to K.
F r equal to K into X. Okay, for linear SHM we get a restoring force equal to K into X. For angular SHM we get torque equal to K into theta. Okay, this is also angular SHM, this is angular SHM, this is also angular SHM. In this case K is torsional constant, and in this case there is no K but 2 pi root over I by mgt, where d is the distance between point of suspension and center of mass, and in this case t equal to 2 pi root over I by mv. So let us solve the problem. All the things are given. I 7.5 10 to the power minus 6, 6.7 10 to the power minus 2, 0.01. Calculate. 7.5 100 10 to the power minus 4, 10 to the power 4, 10 to the power minus 2 by 6.7, 2 pi by 10, 10 to the power minus 2, 1 by 100, 1 by 110, 10 to 5s are into root over 75 by 67, pi by 5 into 5 root 3 by root over 67, 5 cancel, equal to pi into 1.73 divided by root over 67, it will be 8 point something, 8 point, maybe 8.1. Try with this pi equal to 3.14. So do some calculation. This is a source of electromagnetic wave emitting electromagnetic radiation. Frequency is 10 gigahertz, and there is an observer who is moving towards the source, and he is moving at half the speed of light. So he will record a frequency nu dash. You have to find nu dash. Here the speed of the wave is very high, okay, and electromagnetic radiation, so speed of the wave is same as the speed of light, and velocity of the observer is also quite high. So we will not use this formula that we use for sound wave, V minus Bo by V minus Bs into nu. This will not use. Okay, we use this formula for Doppler effect in light. Doppler effect in light. The formula is nu dash equal to root over C plus B by C minus B into nu. Root over C plus B by C minus B into nu. Okay, this is valid when observer moves towards source, or another formula is and nu dash equal to C minus B by C plus B into nu when observer goes away from the source. Observer goes away from source. And what exactly is B? What is B? C is the velocity of light, but remember V is relative velocity between the source and the observer. It is the relative velocity. You will put the value of the relative velocity. Okay, V is the relative velocity. Relative velocity between source and observer. Okay, so in this case the observer is moving towards the source, so we'll use this formula. Let us now solve the problem. Root over velocity, relative velocity between the source and the observer. Source is stationary, it is not moving, so velocity of the observer itself is the relative velocity. So C plus C by 2, C minus C by 2 into nu equal to root over 3C by 2, 2 by C into nu, so root over 3 into nu is 10 gigahertz, 10 gigahertz, root 3 equal to 1.73, so 17.3 gigahertz. Consider an example of SHM. This is executing SHM. It is passing through the mean position with maximum velocity. Passing through the mean position with maximum velocity. So here the kinetic energy is obviously maximum. Then here the particle comes to momentary rest. For a moment it becomes stationary. So at the end position velocity equal to 0, then kinetic energy is also 0. That is minimum. Okay, minimum. So let us now eliminate the options. So starting at t equal to 0, according to the problem, at t equal to 0 the particle is at the mean position. And at the mean position it is having maximum kinetic energy. But this diagram is showing that at the start kinetic energy is minimum. So this is wrong. This also shows it is wrong. Okay. Now one of these two is to be correct. Okay. Because this shows a maximum kinetic energy at t equal to 0. This also shows a maximum kinetic energy at t equal to 0. Okay. Then we have discussed that at t equal to t by 4. At t equal to t by 4, 1/4 of time period, starting from this point, t by 4, back to this, another t by 4, means t by 2, to this point, 3t by 4, back to this, t. This is one period. So after t by 4 time, the particle reaches the end position, hence kinetic energy becomes 0, not after t by 2 time. So this is the correct. Consider this room, door is open, okay, pressure is constant, okay. Now temperature is increased. What happens if temperature increases? The molecules will move away from each other, okay, density will drop, okay. So if you increase, if you burn, if you light a heater in this room, what will happen? Air will go out or air will come in? Go out. So simple conclusion, final number of molecules, will it be greater than initial number or final number of molecules will be less than initial number?
Less than initial.
Just burn a heater in this room, air will become hot, doors are all open, air will go out, so final number of molecules is obviously less. Air has gone out, mass has gone out, the final number of molecules is obviously less than the initial number of molecules. So you can easily cancel two options. Since final is less than initial, So you can easily discard this.
B and C.
Easily discard. Now one of these two options is correct. Now find Ni equal to N1 T1 V1 by RT1 Nf N2 P2 V2 by RT2 Ni minus Nf equal to Nf minus Ni, Nf minus Ni equal to P2 B2 minus P1 B1. P is same in both the cases, volume is also same in both the cases. So P into V by R 1 by T2. Final temperature 300 Kelvin. In final number of molecules. So we are calculating number of moles. Then we will multiply it by Avogadro number. So P into V by R 1 by T2. T2 means 300. T1 290. Pressure 10 to the power 5. Volume 30. R 25 by 3 minus 10 divided by 300 into 20 equal to or 0 0. So 3 is a 1, 3 will cancel. Okay, and 10 to the power 4. 3 into 10 to the power 3 into 10 to the power 4 by 25 into 29. This is moles. Difference in moles. Hence, change in number of molecules. Change in number of molecules equal to del moles into N Avogadro 3 into 10 to the power 4 by 25 into 29 into 6.023 into 10 to the power 23. Okay, for calculation purpose take it to be 6. 2.5. Okay, so option 4, option B is correct. Cp minus Cb equal to R, molar. These are called molar specificates. Molar specificates means per mole basis. Heat required for 1 mole. Molar means heat required for 1 mole. Okay, so but here just specific, it's not molar. That means here Cp and Cv not per mole basis but per gram or per kg basis. Okay, so consider this. Say in thermodynamics you have learned this formula N into C into dt, and in heat chapter you have in class 10 level del Q equal to mc into del T. This C is what? See, M into C means this is per mass, per unit mass. Okay, so this is what is given here. Okay, so in order to know the relation between molar specific heat, that means per mole, specific per mole and specific heat per kg. Okay, just if you forget in example, just consider this case for 1 mole of oxygen. How much? Cp or Cb, anyone you consider. Say Cp. For 1 mole, capital C. So for how 1 mole of oxygen means how much? 32 gram of oxygen. 32 gram of oxygen, it is Cp. And what is this small c? 1 gram. For 1 gram of oxygen, Cp by 32. Okay, so that means we can write, this is what? Per gram means this is small c. So small c equal to capital C by m. Okay, small c to denote, I am using small c and this one is capital C. Small c equal to capital C by m. Okay, so small Cp minus Cv. So small Cp minus Cv equal to capital Cp by m, capital Cv by m. Okay, or we can use this, or Cp minus Cv is what? Cp minus Cv R. So remember, small Cp minus small Cv equal to R by m. Memorize it. Again, this problem will come in your time because this has been coming since last 20 years. Similar problems are coming every year. So small Cp minus small Cv equal to R by m. Capital Cp minus capital Cv equal to R. Small Cp minus small Cv equal to R by m. Okay, so now I'll put this in box. Okay, Cp minus Cv equal to R, small Cp minus small Cv R by m. This is molar. This is per kg basis, per unit mass. Put this in a box. Okay, so Cp minus Cv. Now I'll answer the question. Small Cp minus small Cv equal to capital R by m for hydrogen, small Cp minus small Cv R by how much is m? What will you put? Do not write 2 because no. What is the molecular weight of hydrogen? 2? What is 2? 2 what? What is the unit?
2 AMU.
2 gram. This is very vital because I have seen many students committing this mistake. Okay, while they should put 2 into 10 to the power minus 3, they are writing 2 and getting wrong answer. Okay, in this problem it will not matter because since you have to find the ratio, it will cancel. But you should know it exactly what. Because for example, in this problem, C equal to root over 3RT by M, RMS speed.
Yes.
Suppose the question has come based on oxygen. What value will you put in place of M? 32 into 10 to the minus 3. Do not just put 32. 32 into 10 to the minus 3. Okay, so that's why oxygen 2 gram, nitrogen 28 gram. Hydrogen 2 gram, oxygen 32 gram, nitrogen 28 gram. So in order to make it mathematically correct, I will put 2 into 10 to the power minus 3. I know that it will cancel. Even then, okay. To stress upon this, for nitrogen, Cp minus Cv 28 into 10 to the power minus 3. Okay, so this is A na, this is B. So A equal to or B equal to R by 2. A by 14. A equal to.
So B equals to 14.
AI equals to 14.
C. A equal to this, B equal to this. Now R by 2 into 14. So A by 14. So that means A equal to 14B.
Yes.
So you have applied pressure on this block from all the sides. As a result, the volume of the block gets reduced. If we apply pressure on this from all sides, obviously the volume will be reduced. According to the problem, then after the body gets its volume reduced, you are heating the body in an attempt to make the body regain its initial height. Okay, so first you have applied pressure, stress from all the sides, and the volume decreases. This is called mechanical compression. Mechanical compression. Mechanical means by applying force. Then you have started heating the body. The body will expand, and this expansion is called thermal expansion. Okay, so if there is no net change in volume, then mechanical compression must be equal to the thermal expansion, because there is no net change in volume. Okay, so mechanical compression followed by thermal expansion. The net change is 0. Okay, since there is no net change in volume of the body, hence mechanical compression equal to thermal expansion. Mechanical compression equal to thermal expansion. For mechanical things, mechanical, thermal. For mechanical things, what do you use? For mechanical things, we use Young's modulus, bulk modulus, rigidity modulus. And for thermal things, what do you use? Alpha, beta, gamma. Okay, so mechanical compression. B equal to del P by or del B equal to del PB by B equal to P is the pressure, actually that is change in pressure, into B by, according to the problem, B is given as K. Okay, thermal gamma del V equal to V gamma into del T. Do you know this formula? Change in volume equal to initial volume into gamma into del T. Change in length equal to initial length into alpha into del T. Change in area equal to initial area into beta into del T. So del V equal to V into gamma into del T, according to the, and gamma, alpha is given na? For this material alpha is given, and I think you need, know the relation alpha equal to beta by 2 equal to gamma by 3. So write B gamma equal to 3 alpha into del T. Since mechanical compression equal to thermal expansion, hence PB by K equal to V into 3 alpha into del T, or V cancel, or del T means initial is 0, or del T equal to P by Pk alpha, del T equal to T minus 0, P by 3k alpha or T equal to P by 3k alpha. Okay, so option A, na? Option A is correct. Copper calorimeter. Mass of the calorimeter is 100 gram, and this contains water. Mass of water is 170 gram. Okay. Then there is a copper ball. Its mass is also 100 gram. Okay. Its temperature is not known, T. Then this ball is dropped in this. Okay. And obviously it will be followed by stirring and all. A final temperature is given how much?
75 degrees.
75. Okay. So final equilibrium temperature with the ball gone underneath water, it is 75 degrees centigrade. Final. Okay. You have to find temperature T. Initial temperature of this water and calorimeter is given 30 degree Celsius. Okay. And specific heat of copper is given. Specific heat of copper 0.1 calorie per gram degree centigrade. We will apply calorimetric principle. Heat gained equal to heat lost. Who gains heat? Obviously the colder body. Here water is colder, so water will gain heat and its container will also gain heat, because the system temperature is 30 degrees centigrade, water is at 30 degrees centigrade, calorimeter is also at 30 degrees centigrade. So heat gained, hence heat gained by calorimeter plus heat gained by water equal to heat lost by copper ball, okay, or heat gained by calorimeter. We know the formula, M into C into del T, M into C into del T. Heat gained by calorimeter 100 gram, specific heat 0.1, final temperature is known 75, so temperature difference plus heat gained by water 170 gram, specific heat of water is 1 into 75 minus 30, heat lost by copper ball, mass of copper ball 100 into 0.1 into
T minus 75.
T minus 75, final temperature is 75, so T minus 75 or 10, 5, 45, 170, 45, 10 into, how much do you get? How much? Solving this? 800
885
degree centigrade. You have to find the angular acceleration. For linear acceleration, see, for linear acceleration, we have this formula. For angular acceleration, we have this formula. Moment of inertia is the rotational analog of mass. Torque is the rotational analog of force. So we'll use this formula. So you have to find the torque. You have to identify the forces acting on the rod. Forces acting. What is the only force that is acting on the rod is mg. Mg is acting through the midpoint. So what is the torque of mg about this point?
mg is equal to sin.
Torque of mg, Shruti. Torque of mg about this point. Perpendicular distance में confusion नहीं होना चाहिए. Torque of ठीक से एकदम. Torque of mg about this point.
mg by
mg into L by L sin theta by 2.
Sin
mg into L sin theta by 2.
So once again, to avoid any confusion. No, to avoid any confusion, this is the line of action. So every time this comes, I explain this so that there is no confusion regarding this. This is what is known as line of action of the force. Line of action of the force.
Yes.
Force multiplied by perpendicular distance of line of action. So this is line of action. Its perpendicular distance from which point? From the axis of rotation. So this is what is known as perpendicular distance. So this angle is, this is L by 2. Perpendicular distance is L by 2 sin theta. This theta. So perpendicular distance is L by 2 sin theta. So or torque of mg, torque of mg about pivot equal to I into alpha, or what is the torque of mg about pivot? mg into L by 2 sin theta. What is the moment of inertia about axis of rotation? ml square by 3. About the end, about the midpoint, ml square by 12, ml square by 3. So m L square by 3 into alpha. Finished. So we get the answer m alpha equal to 3g sin theta by 12.